side is not gluey, okay? It is only a little bit sticky, but it will not get you stuck. That side if you go, that might be a problem. By tomorrow should be fine. Okay. Everybody quiet. Okay, so what are we going to learn today? Does anybody know the plan for today? Yes, Deekshita.
Slope and slope intercept.
Yes. We'll talk about slope and slope intercept. And let me do one thing. Arav, why you have to cry for everything? Why you have to cry for this? Yug, my neighbors are better than you. They are not making as much noise as you are making just after coming out of the class. Class has started. Okay. And do one thing. You stay inside. Because if you stay here as if you are not here. So zero sound. Alright. So we are going to talk about, okay, but yeah, Arav, what was the reason for crying?
Oh, it's because I really don't like slope.
I'm sorry?
Oh, I really don't like slope, that's why.
You don't like slope? You have never used a swing or a slope in the kids park? Have you used that slope, the slides of the kids park? No? You don't like them?
My dad is.
Okay. Slow, don't run. Careful. It's okay. Okay. So, okay, jokes apart. Now we are talking about slope and intercept. So what do you guys know about slope? Okay, Adrik, explain that to me in the simplest possible form that you can. Adrik, go ahead, unmute yourself. Hello, Sammy. Okay. Who can explain me what is a slope and what is an intercept of a line? Let me be more explicit. So what do we mean by slope and intercept of a line? Who can describe that to me in the simplest possible form? I'll not take your bag, but you can keep it. She's holding like this, somebody is going to steal it. I'll not. Keep it here, it's okay. Take your notebook out and make sure that you are scribbling enough when I'm teaching, okay? Alright. Who will explain me what do we mean by slope and intercept of a line? Tasvik, any luck? You have done enough research with my floor, not let's talk with math. Okay. Yes, Sanvita.
A slope is like how steep the line is.
Uh-huh.
And then an intercept is when the line crosses one of the y or x axis.
Yes. So intercept, intersect, similar words. Okay. So this is, let's say, if you're talking about a coordinate plane. This is a coordinate plane. Okay. This is my x-axis. This is my y-axis. Okay. If I say I have a line, straight line. Any and every geometrical shape that we talk about, we have to recognize that by certain properties or certain things that describes it. Okay? If I say circle, you'll say, okay, it has a radius and you want to know where the center is. That describes the circle. If I'm talking about a line, this line is different from this line. It's different from this line. It's different from this line. It's different from this line. All the lines are different. Why? Hello, Adya. So, Adya, today we are talking about slope and intercept of a line. Okay? So, right now, I'm just messing around with what I have on the board. Okay? So, I'm saying that I have a coordinate plane. When I say coordinate plane, I'm talking about an x-axis and a y-axis. I'm saying this line, this line, this line, this line, this line, this line are all different. And how do you describe that? Yes, Advik, you are saying something. Give me a description. Educate your teacher.
They're like all different because they have like different angles and different positions on the graph.
Okay. Any other point of view? Yes, Arihan.
If they were the same, they would all just be like stacked in dots in the same.
I could barely follow you. Say it one more time.
Like if they were the same, it would be like stacked on top of each other.
Okay.
They're on the same coordinate on the graph.
Okay. Arif?
One of the lines are going up and one of the lines are going down, like they're like in different directions.
Okay. Sami?
If they were all the same, then there wouldn't be anything to differentiate them or like what kind of thing they are. Or like you couldn't do anything with it.
Okay.
You couldn't make a map out of it.
Okay. Advik, you have told me your story already. You still have something to add?
Like some of them are positive slopes and some of them are negative, and like only one of them is proportional.
Okay. So, I heard a lot of things from you guys. And if I put that in one line, or maybe two lines, see, I borrowed knowledge from each one of you, and I'm just collating that and putting that in one or two lines. Hi, Kumari.
Hello.
So today we are talking about slope and intercept of a linear equation. Okay, and so far we have not covered anything. So you have not missed anything. It doesn't mean that we should join late, but so far no damage done. Now, for me, any line can be described by two things. One is the slope, meaning how steep or shallow it is, okay, and where it touches the x and y axis. So now every line that you draw will touch either both the axes or at least one of them. Okay, you will not be able to draw a line that doesn't touch any of the axes. Okay, it has to, because line has no end point. You cannot say my line is like this. This is not a line, this is a mastic. Line segment actually, yeah, spot on. This is not a line. Line means there is no end, meaning you have to stretch it as far as you can without scribbling on the wall. Yeah? So you will see that any lines has to touch one of the axes for sure. So what I'm coming down to is that any line that you have to describe can be described by two things. One is, okay, so I see somebody with name Samyut. What's your name, beta?
Hello?
Yep, what's your name?
Samir, I came to your class last week on Sunday.
Oh, okay, Samir. So that's why I was wondering, where's Samir? Samyut. Okay, so everybody keep your video on so that way I don't ask dumb questions in between, okay? So, any line that we talk about can be described by two things. One is the slope and where it touches the x or y axis. Now you will say, why? Is that enough? I'm saying that any line any line for that matter can be described by the slope. Let's say this is the slope. This steep, okay? And this is where it touches the x-axis. This is my x-intercept. This is where it touches the y-axis. This is my y-intercept. This much is my y-intercept. This much is my x-intercept. Now you cannot draw a second line with the same slope and same x and y-intercept. You can draw it. You can keep drawing on the top of it again and again, but eventually you are drawing one line. Yeah? So, every combination of slope and the x and y intercept is unique. So, if you have to describe a line, if you could describe the slope of that line and the point where it touches the x and y axis, that's a unique thing. That's a unique behavior, right? If you guys have to describe me as a person, what you need to know? You need to know my name and my social security number. That's it. There is no second person with the same social security number and same name combination. Likewise, when you have to describe one line, every line is so very unique by the slope of it and the place it touches x and y axes. Is that okay, or I'm just getting you guys overloaded? Everybody okay so far? Kumari, Sanvita, everybody clear? Dikshita?
Yes, sir.
Okay. Now, what is a slope? I have been blabbering about the slope for last so many minutes. What is the slope of a line? In mathematical terms. So that was Abhiram thinking about it, okay? I want to give chance to everybody. So Kumari, can you tell me beta, what is your understanding of a slope of a line? Or Urvi? Yeah, I'll come to you beta. Yep, yes Kumari, go ahead.
A slope is y equals mx plus p. So, like, that's the equation, but like slope is m invariable.
Okay, slope is m invariable. That is a very mathematical response. Okay, let's see what Advik says.
Slope is rise over run.
Arav, do you have a same definition or different definition?
Could you rise or run to calculate where the y-intercept is in the actual y chart, so we can determine where
No. Don't tell about the whole book. I'm just saying what is slope. And one response I got was rise over run. Is your definition different from that? No. Okay. Sammy?
So, slope is like, it's kind of hard to explain, but yeah, basically rise over run.
Rise over run. Okay. So, Shaurya and Abhiram, Myra, Vasundhara. Slope, now look at this. This one has some slope. Is this slope more than this or less? Is this slope more than this or less than this?
Less.
This has less slope. Meaning if this is your slide, right? Here you will slide slowly. Here you will slide fast. You will slide faster. Very fast. You just drop. You will not slide. Yeah. So this is very high slope, less slope, less slope, less slope, even less slope, even less slope. Yeah. Relate that with your childhood when you used to slide down in a park, right? Now, some of you were describing that as a rise over run. This is run and this is rise, correct? You are going up is rise. Here. So let me give you another example here. See, if it was a computer, I would have said Control Z and would have deleted everything. That would have been easy. But I'm still in the old school. So now let me draw another line. Okay? This side is run. This side is rise. So here, look at this slope and look at this slope. This slope is more, this slope is less. Yeah? This slope is even less. I'm just stretching this discussion to make it easy for you guys to comprehend, okay? Now this slope is less, more. This is a slide. I'm just kidding. Now this is a slide where slope is so much that you sit here, takes no time for you to come here, right? So this is the highest slope. Now rise over run. Look at this. For every run, let's say if I move 1 unit, see how much this guy changed. Y value changed from here to here, only this much. This my rise is, let's say this is 0.2. For this is slope, okay? Rise is 0.2 and for 1 unit of run. Now look at this guy. Here it changed how much? From here to here. This will be probably 0.5, much more than 0.2, right? Yeah? If you are looking at this line, here you found rise is only 0.2 this much for 1 unit change. You extend this line, see here, how much y has changed? It has changed by this much, which is much more than this guy. Yeah? So you are, for the same amount of run of 1, here your rise is much more. Look at this guy here. Between here to here, for this much of run, how much is the rise? See, here to here. Yeah. Am I able to describe it okay so far? Everybody able to follow me? Kumari, Charya, Vasundhara? Yeah? Adya? Everybody okay? So, when you look at less slope versus more slope, it simply means my rise over run is getting higher. Meaning, for small travel along the x-axis, my value of y is changing so much when my slope is increasing. Yeah? Or, you can tell it mathematically now that my slope is always rise over run. Meaning, for every change in the run, how much is my change in the rise? Or, to be even point blank, you can say, for every 1 unit of run, how much is my rise? So here in this case, you saw your rise was 0.2. I mean, I'm just making it up. Some relative number. For 1 unit of run. In the second line, so this here your slope was 0.2, let's say. In this case, you saw that for the same amount of run, your rise was probably 0.5. When you saw a bigger, higher slope, you saw that for the same amount of run, your rise is probably almost 4 times of this one, maybe 2. Yeah? So this becomes our mathematical definition of slope. Meaning, for every change in x, or every run, how much is my rise? For every change along the horizontal axis, how much is my change in the y-axis? That is my slope. Is that clear to everybody? Urvi? Okay, sorry, Urvi? Urvi, I have to get little younger. Otherwise I'll keep on messing up with everybody's name. I cannot get younger anyways, but I have to eat more almonds maybe to make my memory work better. And you guys know, right? Almonds will make your memory better. Make sure you guys are eating almonds too. My exams are done. You guys have your exams coming up, coming years. Keep eating a lot of almonds. Alright, so coming back to this one, my slope of a line is rise over run, meaning how much is my y value changing for every change of x. Yeah? Hiranya okay? Aradhya okay beta? So far?
Yes, sir.
Okay. Now, okay, everybody understood what is the slope, rise over run. How much is my y changing for every change of x? So what is negative slope then? What is positive and negative slope? Who can describe that to me in layman's term? Not Advik this time, not Sammy Arab this time. I want everybody to participate in the class as well. Samir, tell me, what is the difference between a positive slope and a negative slope? How do we describe that? Explain that to me like I'm a 5-year-old guy. I'm only 5-year-old, that Krishna is thinking. See, 0 has no value, right? Next year I'll turn 50. So 0 has no value, so I'll remove 0. I'll become 5. So explain that to me like you'll explain that to a 5-year-old. Yes, Arihan.
I mean, if you're going in a negative slope, I think it would be like defying gravity, kind of. If you're on a slide and you have a negative slope, you would be defying gravity.
Is it defying gravity or complying with gravity? Sanvita, tell me, what is your response?
A positive slope is like when your line is going upwards from left to right, and then a negative slope is when the line is going downwards from left to right.
Exactly. Advik, is that your response too?
I was gonna say it's like a positive slope, like it goes out in the first quadrant, but a negative slope, it goes out in the fourth quadrant.
No, I will not relate that with quadrant, okay? Because I can have a positive slope.
I got
Okay.
both quadrants.
Yeah. So let's decode this a little bit more. If I'm talking about a positive slope, okay? What is slope? Rise over run. Meaning my change of y is change of y versus change of x. Yeah. When my y is changing. If I'm talking about a line like this, my y value is increasing. Yeah. For every change of x, my y value is decreasing. So y, this point to this point will be a negative value. When my x is increasing, going in this direction, my y is decreasing. See? More I increase, more decreases. It's like you are trying to pacify a baby who's crying, and you are giving more milk, and the baby cries more. Yeah? So this is a negative slope. So Arihan, to your point, this is complying with gravity when you are going to talk about negative slope. When you talk about a positive slope, you are defying gravity, you are going against gravity. Yeah? Yeah. So coming back to this point, when you're talking about negative slope, meaning your rise over run is negative. And that will happen only when your y decreases for every increase of x. When y decreases, and this is a scenario when y decreases. So it is always when it's moving downward, meaning your y value is decreasing for every increase of x, that is negative slope. And when it is moving upward, that is a positive slope, meaning for every increase of x, your y is also increasing. Now, Advik, to your point, it has nothing to do with any quadrant, because I can have a positive slope in second quadrant and I can have a negative slope in fourth quadrant also. Yeah? Depending on where the line is placed. Is everybody clear? Arab, go ahead.
So then what if the line is like usually straight.
You tell me, how do you describe it? Think about it like a mathematician. I don't really care whether it is upward, downward, or horizontal or vertical. I only know one formula, rise over run. Okay? I'm making your job easier, okay? I'm saying that I will stick to one approach. Say, okay, my slope means rise over run. Okay? What is my rise here? When I'm changing from x from here to here, when I'm increasing my x, what is my rise? I'm talking about a horizontal line. My rise is 0. I'm not risen at all. When my x changed, this is my slope. 0 over any number. What is that? 0 slope. 0 slope is no slope. 0 money is no money. Yep. Take this situation. I wish we never go on to a slide like this. Smaller slides are okay, 1 foot, okay. If you're talking about a 10-foot tall slide like this, keep your first aid box ready. This is a very bad slope. Why bad slope? Look at what is the slope. Without any change of x, meaning x did not change. My change of run is 0. And it's a vertical line. So without changing, my y value is changing from any negative to any infinite number, okay? Good that my wall is not tall enough. Otherwise I would have kept on drawing it all the way till I could reach. Yeah? So my y could change from infinity to infinity. So I'm talking about infinity divided by 0. Infinite slope. Always go to a slide which has finite slope. Okay? Hiranya okay? Kumari okay?
Yeah.
Abhiram, with me beta? Aradhya, which slope do you like? Infinite slope, 0 slope, or something in between? 0 slope will be no fun. You'll just sit in one place. Infinite slope will be harmful. Something in between. Yep. And again, don't go on a slope like this. If you're sitting here and hoping to climb up, you're defying gravity. You cannot go on this one. Better slide from here to here. Okay? So positive slope, negative slope, 0 slope, infinite slope, we understood. And by looking at the graph, we could at least relate that with the fact that just by seeing the lines or their orientation, yep.
Can I go to the bathroom?
Make sure that you're not going to that side. Go from this corner, okay? If you get glued, that's a problem. Okay. So, go to the side, go to the side, go to the side. Yeah. Oops. You're able to come out? Okay. Okay. That's what I was saying, to go by the side. It's okay, you're fine. Take out your shoes and go. Take your shoes out and go. So this is epoxy I was putting on the floor to make it look better. It is still not dry yet. Okay. And I could not cancel the class. That is not good. Okay, so by looking at the diagram itself, we can make out which one is a positive slope, which one is negative slope, which one is 0 slope, which one is infinite slope. Yeah? Everybody clear about that? And this is the basic understanding now. Next thing that I was talking about is that any straight line that you talk about can be described by 2 key elements. First one is slope and second one is x and y intercept. And what are those? Meaning, if I have a line where it's touching the y-axis and where it's touching the x-axis. If I know this point and if I know this point or one of the point, okay? Even if you say, okay fine, I know the slope of this line and the point it touches. Okay, give me one intercept, that's enough. Because I cannot have same slope but different lines touching this point. Okay? This is not the same slope. It has to coincide with this. So, one intercept, either x-axis or y-axis, as long as you know and you know the slope of the line, that is more than enough for us to describe a line. Is everybody with me? Shaurya, Vasundhara, Arihan, Sanvita, Samir. Samir, okay? Is it clear? So, okay. So, Tasvik, you have to do a little bit of gymnastic. Meaning, come from this side, by the side, the dry side, okay? Don't go on to the shiny stuff. Come here. You guys are too scared. Come here. No. Lift your leg. Give your hand. Yep. Come by the side. Now you're fine. Okay. It's only for today. Tomorrow will be fine. Okay. So now we have looked at the basic building block of a line needing slope. How do you describe a slope? How do you talk about intercepts? So Kumari, you were talking about the slope-intercept form y equal to mx plus c. That was a very loaded response to begin with. Now with all the blabber I have done, now we can relate to it. I was saying that any line that you talk about, if you know the slope, and any of the intercept, x or y intercept, meaning where it touches the y-axis or the x-axis, that describes the line. This is your line. This is your slope, and this is your y-intercept, meaning where it touches the y-axis. Yes, Arav. Ask me only if there is a valid question.
Wait, what are the parents meaning?
What is that?
What are the parents meaning?
One more time.
What does the M and the C mean in like the formula?
F is the slope of the line. So we are talking about a linear equation where y equal to mx plus c. This is the slope intercept form. So this says, one second, I'll tell you what I have to do. We worship this. So, okay. So when you talk about y equal to mx plus c, your m is the slope of the line and c is the y-intercept. Yes, Kumari?
It's not B.
No, y equal to mx plus c. I mean b, I mean you can, see, c is a constant, okay? You can put it a b, you can put a d, you can put it a z, but this is your y-intercept, meaning, now let's decode this. This is your line, as we discussed that, okay, if I have, Tatvik, don't do that. If I have a line, meaning I have the slope known for me, saying slope is 2, meaning, slope is 2 meaning what? For every change of x by 1 unit, my y changes by 2. Okay? That's my slope. So I have a slope of 2, let's say. What was I trying to say? Okay, so yeah, so this, depending on whatever the slope, I will replace that with m. And then this c says, this is the point where it touches the y-axis. Now, any straight line, whenever it touches the y-axis, what will happen to x? Any line, see, my questions are not difficult, I'm just making you think, okay? Any line when it touches the y-axis, what happens to x at that point?
Does it like turn to zero?
Yeah, exactly. When your line touches the y-axis, on every point on the y-axis, x value is 0. Similarly, whenever your line touches the x-axis, every value of y will be 0. Yeah? These are like enemies, okay? There is no point on y-axis which can afford to have x value more than 0. There is no point on x-axis where y can afford to have any value other than 0. They don't go well with each other, okay? They don't like each other actually. Though they complement, but they don't like. Okay? Now, again, all the examples are plain, but more from understanding point of view. Alright? So here, now look at this. When it touches the, let's say I have a slope of 2, meaning for every change of x, y rises by 2. So let's say in this equation becomes y equal to 2x plus c. Now, when it touches the y-axis, meaning what will happen? My x value will be 0. So y will be equal to c. Yeah? If somebody says, okay, what is the x-intercept? Meaning when this line touches the x-axis, at what point touches the x-axis? Whenever it touches the x-axis, meaning that point y will be equal to 0. So I will put y equal to 0 in this equation and try finding out the value of x for which it touches the x-axis. Now, any questions with respect to what I have been talking so far? How do you relate it with the slope-intercept form? And now I'm going to give you guys a nightmare. In the bright sunlight, do you get nightmare? You cannot. It is just about doing some mathematical problem with a very open mind without being scared. Okay? If anybody has ever got a nightmare in the bright sunlight, let me know. I have equation x plus 3y equal to 15. Okay, this is a equation. This is a linear equation, okay? Because every power of the variable is maximum 1, right? So it's a linear equation, meaning it will draw a line. I'm saying find out the slope and x and y intercept of this line. This is a problem I want everybody to grapple with. So let me repeat this. I have an equation x plus 3y equal to 15. This is an equation for a straight line. It's a linear equation. I want you guys to find out the slope of this line and also the x and y intercept, meaning where it touches the x-axis and where it touches the y-axis. Let's see how soon we can find this. Adya, Tasvik, make use of a notebook. Make sure that your hands are at least this much dirty. Go ahead. Can I assume everybody's trying? Saurya, Abhidam, Arihan, Vasundhara, Kumari, Samir, Sami, Suhina. Suhina has been very quiet today. What happened, beta? All okay? Aradhya, everybody is trying, right? Here in the classroom, all the kids with a sticky floor, trying? Okay. Give it a try. See, what if you, even if you are scribbling, as long as you're not drawing my picture, it's okay. Try something. I have given you the equation. I am saying find out the slope and the x and y intercept. I have somebody with name Tejas. Who is Tejas here? Tejas, can you unmute yourself? Tell me your name, better. I'm seeing you for the first time. Okay. He got scared of the nightmare. Okay, Yadvik.
How do you find the x-intercept again?
Yeah, you have to find out x and y intercept as well as the slope. And I might not have explained everything. I want you guys to apply your thoughts. Decode this by yourself to some extent, and then if you guys are not able to do so, I'm here, don't worry. What's happening? Give it a try. You can start from even from here. See, whenever I get, that's what I was saying, right? Make sure that you are scribbling. What? Okay, it's a straight line. Okay, let it be like this. It's a straight line. And then what? Tejas, can you unmute yourself and tell me what's your name? Okay. Somebody is having fun. Okay. Let me become a student for next. I'll give you guys 5 minutes. Okay. I'm here. Okay. Now, let me be with the kids here. Okay. 3 hours of standing, it becomes fun. So, who will be last week? Here. So, we are talking about this. Come here, come to x plus 3y equal to 50. Okay? What do you think we are trying to find out? X intercept, y intercept, and slope. Yeah? Guys, you guys are not listening to me, right? Don't. Do it yourself. I'll be there in 2 minutes. Now, see, look at this. This is what I was saying. This is a line. What will be my y intercept? Meaning the point where my x value becomes 0. Okay? So I'll put x equal to 0 here. 0 plus 3y equal to 50. 3y equal to 50. Y equal to 5 over 3.
Oh yeah.
Yeah. Okay. So we got the y intercept where it meets the y axis. Similarly, what is my x intercept? Where on the x intercept, bringing on the x axis, my variable is always 0. So I'll put a y equal to 0 here. X plus 3 into 0 equal to 50. So x equals x plus 0 equal to 50, or x equals 50. We got our x intercept also. Now the slope. This one I'll disclose when I explain everybody. Okay. But see, this is not difficult. So what I'm saying is, the problem is when we don't start. When you start scribbling, keep getting used to the habit of getting your hands dirty. You can watch it later. That's okay.
What is good, my idiot?
Who is this?
Somebody random joined.
Okay. Who is this? Who is making that unnecessary sound?
The person who randomly joined and left.
Okay,
Yeah, I think his name was like Judge Jones or something like that.
that's okay. We don't care about.
Yeah, it was that's
Yeah, okay. So who got the answer? Any? Yeah, Advik. Arav, you start. Tell me, did you get the x and y intercept?
I actually ask a question. So does a linear equation it have two like equation to it? You know, it makes it a line.
Yeah, every linear equation, every equation where the maximum power to the variable is 1, that has to be a linear equation. That will be a linear equation. Yes, Advik, tell me, what is your find so far?
So for like, okay, so for y, I got like,
What is y?
for the equation, I got y equals negative x over 3 plus 5.
Y equals negative x over 3
minus 5.
minus 5. Okay, you change the
Oh, wait,
equation.
plus 5, plus 5, plus 5.
You converted this to this form. Okay. Okay.
And for x, I got x equals 15 minus 3y.
Okay. I will come to you. Kumari, tell me what.
I got the y-intercept, x-intercept, and slope.
Uh-huh. And how much is that? How much are the values?
For x-intercept, I got 15
Uh-huh.
and 0, like the point.
Uh-huh.
And that was for x-intercept.
Uh-huh.
For y-intercept, I got 0 and 5.
Okay. How about the slope?
Negative 1/3.
Okay. Okay. So just in the interest of time, before Mr. Tejas Weldy joins again and starts making some crappy sound, let's come back to this problem. This problem was simple. We had a linear equation. Everybody here. X plus 3y equal to 15. Just 5-10 minutes ago, we were talking about this equal to y equal to mx plus c is the standard form of a slope-intercept form. If you have your equation in this form, this is your slope and this is your y-intercept. Unfortunately, our equation is not in that form. Okay, we don't have y on one side and everything else on the other side. Who is this? CMP wants to go pro. Okay. He will go pro to places. Okay. Alright. Coming back here. So, we don't have our equation in this form. So, we cannot do it something straight away. But, without doing any calculation or without thinking too much about it, it just says find out the x and y intercept. Meaning where it touches the x-axis and where it touches the y-axis. X-intercept meaning wherever it touches the x-axis, my y value has to be 0. Meaning if I put a 0 here in this equation, x plus 3 into 0 equal to 15. So x equal to 15. So on this place where my coordinates are 15, x value is 15 and y value is 0, this is my x-intercept. I know this is not looking like the right point because I have not drawn it correctly. This is the second quadrant here, my x value has been negative. But, okay. This is a better line. 15, 0 is my x-intercept. Now, similarly, what will be my y-intercept? Meaning where it touches the y-axis. And on that point, my x value will be 0. So let's put a x equal to 0 and see where it touches the y-axis. When I put x equal to 0 plus 3y equal to 15. So y will be equal to 5, meaning x value 0, y value 5. Again, this point doesn't seem to be right. Yeah? Yeah? So, basically my line is like this. So here it is 0, 5 and 15, 0. These are my x and y intercept, which is matching with what Kumari said. Correct, Kumari?
Yeah.
Now, see from this, don't make a sound. From this itself, what do you see? It's a positive slope or negative slope? It's a positive slope or negative slope? Think about it. Negative. Why negative? Because when your x is changing, y is decreasing. Yep. Yes, Adya.
I was actually about to say the
Same thing. I borrowed from you, better. Okay. So again, whenever you see it going down, meaning what does it mean? Visualize it. Okay. Think this way. That when my x value is changing, when I am going in this direction, my y is going down. The slope is negative. When my x value is changing, when x is increasing, it's going up. This is a positive slope. Yeah. Alright. So we saw from this we found out the x and y intercept. Now we know that by the picture itself we see that okay, my slope is negative, but how much? So I don't have my equation in the slope intercept form. Who is stopping us from converting the slope intercept form? Nobody. Nobody can do that, right? Even the Tejas Weldy joins again, he cannot stop us from doing that. Correct? I have the equation. What I need is y on one side, everything else goes to cross the border. Correct? Now if Tejas Weldy joins this time, I will ask him two mathematical questions. Then this guy will either come back to learn or will disappear forever. Yeah? Okay. So now I have this equation. I have to put y on one side, everything else moves. So here x plus 3y equal to 15. So I will keep only y thing in one side, move x to other side. It becomes 15 minus x. Okay. Now I have to keep only y, not even 3. So butterfly, y will be equal to 15 over 3 minus x over 3. Yeah. 15 over 3 gives you a 5 minus x over 3. Or I can write this as y equals minus x over 3 plus 5. Now, I want to keep x separate. I will say minus 1 over 3 times x plus 5. Yeah? Now there is a perfect match with the slope intercept form. Here I have m, here I have minus 1 over 3. So Adya, what is my slope here?
For the
Minus 1 over 3.
oh,
Yeah?
it's negative.
Negative 1 over 3. Yeah. It's a negative slope, right? As you can see. See? This is going down, right? So how did I derive? I did not do anything magical, right? I had this equation. I knew that this is a linear equation. So I converted into this form. I tried getting it close to this way of writing, right? So I had to keep only y on one side. I moved everything other side. And this is what I got. Y equal to 15 over 3, that is 5 minus x over 3. My form is like y equal to mx plus c. So I moved x forward and then I'm comparing it with this guy. See, this is my this is my y-intercept. C is my y-intercept. Look at the y-intercept. See, it's matching with that guy. Yeah. So even if we found the y-intercept in a different way, with a conceptual approach, we see it matching here also. Correct? Mara, is that clear to you?
Yes, sir.
Samir, are you with me? Samir, just a question to you, but I'm just trying to make sure that everybody is with me so far. Gayatri has given a thumbs up. How about Aradhya? Clear? Saurya is okay, Dikshita is okay. Everybody seems to be okay. So that's the good news. And the good news is, we are almost done with the class. Any questions anybody has before I let you guys go? Apart from Tasvik asking me about why the floor looks wet. And Tasvik is going to be stuck because his shoes are having the glues that he's going to carry and he'll be stuck wherever he goes. I'm just kidding. Okay. Alright. So with that being said, I will let you guys go 5 minutes early. Take some rest and we will talk about new concept tomorrow. We'll not do a repeat telecast of this and we'll learn something else tomorrow. Yep. Nihan is thinking what? Arav is crying so much. Why Arav? No? So,
It's because I enjoyed slope so much.
huh?
It's because I enjoyed slope so much.
No, I could not hear it. Say it one more time.
It's because I like this slope so much. It's so easy now.
It looks easy now. Okay. Yeah. I mean, that's what we are trying together. And at times I would explain things the way I understand, right? But if you find it difficult, I keep asking each one of you to ask me questions. Okay. I'm not certainly the best teacher when it comes to explaining things. I keep on learning when I do it over and over again. So if there's something that is not clear to you, don't hesitate, don't be shy, ask me questions. I will find an alternate approach to make it easy for you guys, okay? Vasundhara, all okay, beta? So then I will let you guys go, enjoy the rest of your evening. We'll learn something more tomorrow. And then assignments when I give, I want you guys to get a little more serious about assignments. Make sure you do your assignment, show it to your parents, meaning walk your parents through what the assignment was and how did you do it. Because when you are giving that story back to your parents, they'll feel more confident. At least they can give me feedback whether no I'm teaching them their students well or not. And it also gives me an opportunity to at least realize that if each one of you have understood the things or not. Because in the class you'll understand, you might forget. That's why we have the video. When you're watching the video, watch it step by step. It's not like a 45 minutes so you will watch and then you will learn everything. Now when you're watching the video to revise it, learn watch the video, then when I'm explaining something, pause it and then note it down. Do it yourself. Then again watch something for 5 more minutes, then note it down. So that way you'll be able to catch up. Yes, sorry.
I kind of missed some of the class, so I'll just watch the video.
Yes, watch the video, and for those classes, see what the assignments are. Try doing those, okay? I'm not creating pressure here. I'm asking you guys to watch the video and see if the video is good enough for you to be able to do the assignments or not. If not, I'm here. I'm not going anywhere. Yeah? Alright? So have fun, guys. Talk to you tomorrow same time.
Thanks, Max.
Bye-bye, 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 bye-bye.
Okay.